Hello everyone. Today I'll explain chapter 22 section 3 for grade 12. Section 3, after we finished section 2, when the radioactive elements produce many energy and produce many things like beta, alpha and gamma rays to be stable elements. Today we'll continue. Nuclear power and the nuclear weapons are important and frequently discussed issues in the world today. How does nuclear reactor produce energy? What is nuclear about it? What problems are associated with nuclear power? Do atomic bombs and hydrogen bombs differ in the way they produce energy? If so, how are they different? First, nuclear change. Nuclear change. For nuclear change to occur naturally, energy must be released. Binding energy must increase. You know, binding energy that comes from the differentiate between the total mass of protons, neutrons and electrons, protons, neutrons inside the nucleus, and the mass, the theoretical mass for the atom produce binding energy, and this binding energy must increase when the nuclear change to occur naturally. Lighter elements must combine and the heavier elements must reduce in size. The greatest stability is 4 atoms with mass numbers between 50 and 60, like this. This is the region of greatest stability. Okay, from here, binding energy per nucleon for nucleon, each nucleon is the mass number of the atom by million electron volt, and mass number A will produce a region of greatest stability between 50 and 60. This is the greatest stability for atoms with mass numbers. Fission. Second, fission occurs when a large nucleus absorbs a neutron and splits into 2 or more smaller nuclei. For example of fission, when you bombard uranium-92 235 by neutron 01, it will produce uranium-92 236. This star indicates an unstable state for uranium, so it will change to another atom to be stable. It will produce the radioactive radiation. The star indicates an unstable state that lasts for about trillionths of second for heavy atoms. Okay, X and Y here can be different combination of atoms that have a total atomic number of 92. Total atomic number 92, and will produce number of neutrons. It will produce what? When you bombard uranium pi neutron, it will produce barium 56 140 mass number, and the krypton 3693, and the 3 neutron 01, 3 neutron. Okay, all of these will produce from uranium when it bombarded by neutron as a pump by fission. A typical fission reaction is shown above. The products barium and the krypton have more binding energy than the uranium. As a result, energy is released. Each fission yields about 100 million times the energy released when burning a molecule of gasoline. And this will produce chain reaction. On the average, 2.5 neutrons are released with each fission. These neutrons are then absorbed and cause more fission. Chain reaction occur, and you can know this chain reaction by or through this video.
Nuclear fission occurs when a large nucleus splits into two smaller nuclei. Normally, fission is initiated when a neutron collides with a heavy nucleus, such as uranium-235. The collision splits the uranium into two smaller nuclei. On average, 2 to 3 neutrons are also produced. Fission is an extremely efficient source of energy. One fuel pellet of uranium releases as much useful energy as 1 ton of coal. The waste created by the process is also small in size. It is, however, radioactive and will remain so for thousands of years. Methods for transferring and storing these wastes are key challenges in the use of fission as an energy source. Currently, 20% of the electricity used in the United States is produced by fission. It also powers the largest ships and submarines in the U.S. Navy.
Okay. After we saw chain reaction, the nuclear reactors. Nuclear reactors are used to produce electric energy in many countries. Reactors manage the fission rate by inserting control routes to absorb some of the neutrons. Nuclear power plants and navy vessels use fission reaction as an energy source for electric energy. Reactors produce radioactive waste, and disposal is one difficulty. Presently, 20% of the U.S. electric power is generated by nuclear reactors. Atomic bombs use uncontrolled fission. Fusion. What is the difference between fission and fusion? Fusion-like elements can combine and release energy as well. Hydrogen atoms have less binding energy per nucleon than helium atoms. Fusion is the source of the star's energy. Hydrogen atoms fuse to form helium atoms. Much energy is released with each fusion. Hydrogen bombs use uncontrolled fusion, first tested in 1952 but never used in war. Fusion as energy source. Fusion reactors are being developed. Advantage of fusion reactors: the fuel source, hydrogen from water, is cheap. The products of fusion are clean and are not radioactive. Disadvantage of fusion: it requires extremely high temperature of roughly 10 power 8 Kelvin to force atoms to fuse. It is difficult to keep the hydrogen atoms contained at this temperature. After that, you can see this video about
when light nuclei collide, they can undergo fusion reactions and release energy. Fusion reactions make heavier nuclei from lighter nuclei. When 4 hydrogen nuclei combine, they can form a helium nucleus. Since 2 of the protons have turned into neutrons, other particles must be produced that will balance the charge. These particles are called positrons. Fusion is the principal reaction that causes the sun to give off light and heat. It releases even more energy per gram of fuel than nuclear fission, and its waste products, primarily helium gas, are relatively harmless. Fusion, however, is not used to produce electricity today. Temperatures over 100,000 degrees Celsius are required for fusion to occur.